Atoms and ions are sometimes hard to find in nature by themselves, and actually things get really interesting when we start combining atoms or ions into compounds. When we combine those into compounds, we produce various new chemicals, and this can be anything from salt to new medications or insulin. When we write our chemicals, we want to write a chemical formula. It has a format of the first symbol with a subscript that shows you how many of that symbol, second symbol, how many of that symbol, and so on. You can have as many elements as are in that particular compound. You can have as many ions as are in there. Typically we have one positive, one negative ion if we're talking about an ionic compound. We'll talk a little bit about what happens with molecular compounds in a little bit. In this example, we have N is the number of X atoms or ions, and we have M of the Y atoms or ions. So if we look at aluminum sulfide here, there are 2 Al3 plus ions, and there are 3 S2 minus ions. Remember, we looked at what the ions are, and aluminum forms 3 plus ions, sulfur forms 2 minus ions, so it's aluminum sulfide here. If we look at magnesium chlorate, magnesium, we have Mg. There's only one of it, so there's no subscript written here. So if we only have one, this subscript is left off because it's assumed that there's one. So there's one of the Mg 2 plus ion, so magnesium is 2 plus ion. Chlorate here is a ClO3 minus ion. There's 2 of them, so it may help when you have these parentheses to write it out so you can clearly see how many you have. So in this, we have Cl3, oops, not 2 there, 2 Cl3O minus. That means we've got 2 chlorines and we have 6 oxygens in this formula. So this helps us to identify how many atoms we have, how many ions we have, and what the formula should be.